Types of matrices. So to solve the problems in matrix, we should know at least the basic types. What are the types are there in matrices? How to apply those even in the problems? Let us see. First, let me show all the 7 types of matrices. First one is row matrix. First type is row matrix. You can see the word meaning in this. So row matrix means a matrix which has only one row is called row matrix. Only one row. There is only one row in the matrix, that's called row matrix. So let's say example, there should be only one row, right? So A, B, there's only one row but two columns. Even you can take -1, 0, 3. So if you see the order, this is only one row but two columns. This is one row and three columns. So a matrix which has only one row is called a row matrix, right? First column, second column, but only single row. Your first column, second column, third column, but only one row. So a matrix has only one row is called row matrix. Next one, column matrix. Column matrix. You can see the meaning in this. Column matrix. Row matrix only one row, right? So column matrix must have only one column. If any matrix, a matrix which has only one column is called column matrix. See the example. There should be only one column. -1, 2. So there's only one column, but there are two rows. This is two rows, but only one column. And same like -1, 0, -1. Any numbers. Here we have 1, 2, 3. Three rows, but column is only one. Three rows and one column. Always to write the order of the matrix, you must write rows first, followed by columns. Any matrix order when you're writing, you write the rows followed by column. So there's only one column, here is only one row. So a matrix which has only one column is called a column matrix. So it's always order will get column place is 1. Right. Next one. Square matrix. We have 7 types. So in this square matrix, you can see the meaning from this word square, right? So actually original the meaning of the square is four sides are equal, so length and breadth must be same. That means a matrix which has equal number of rows and columns. Rows and columns are equal, there is a square matrix. Now my 2 minus 2 0 1. Observe this, 2 rows 2 columns. So here is rows, number of rows should be equals to number of columns. Number of rows must be equal to number of columns is a square matrix. Sorry, it's equal. Change this. Rows and columns are equal. Rows is equals to columns or number of columns. Number of rows exactly equal to number of columns. There is a square matrix. Even this 2 rows 2 columns. Let us take one more. 3 rows 3 columns. 3 minus 1 0, 1 4 6, 3 minus 1 5. There are 3 rows and 3 columns, right? A matrix which has an equal number of rows and columns is called a square matrix. Now in case if it is not equal, that is fourth one, a rectangular matrix. Generally if you see the rectangle property, the length and breadth is not same. So same method, same meaning will apply in this. Rectangular matrix is rows is not equals to, so number of rows not equals to number of columns, right? Number of rows not equals to number of columns. So let's take 3 minus 1 0 1 4 6. Observe here 3 rows, 2 rows and 3 columns. This is row 1, row 2, column 1, column 2, column 3. So 2 rows and 3 columns. So number of rows are not equals number of columns. A matrix in which the number of rows are not equals to number of columns is called a rectangular matrix. And fifth one is the zero or null matrix. Zero word is there, no null. If each element of the matrix is zero, it's called the zero matrix or null matrix. Every element in the matrix must be 0. 0, 0, 0, 0. This is 2 rows, 2 columns. All are zeros. Even 0, 0, 0. 3 rows, 1 row, 3 columns. 1 row, 3 columns. So this is the 0 matrix. If each element of a matrix is 0. That's all. So it's called a 0 matrix. And next one. Diagonal matrix. Diagonal matrix. So actually now diagonal is only come for the square. Means first row, first column to last row, last column should have the straight line, which must be square only. A square matrix which has all its elements is 0 except those are leading in the principal diagonal is called diagonal matrix. Let me show example. So only in square matrix like 2, 0, 0, 3 or one more 5, 0, 0, 0 minus 1, 0 and let me take 0 here 0, 0, 3. If you observe here, a square matrix, these both are square matrix. So this is a 2 rows, 2 columns, 3 rows, 3 columns. Principal diagonal, first row, first column to the last row, last column. First row, first column to the last row, last column. A matrix which all its elements 0, each except those on leading diagonal is called. Except those on the diagonal, remaining elements must be 0. So that type of matrix, those matrices only called diagonal matrix. Right. Now based on this diagonal matrix we have the one more type, unit matrix. Unit matrix is diagonal matrix value should be always 1, remaining are zeros. Here we have 2 0 0, right? It must be 1 0 0 1. All the diagonal elements must be only ones. If you write 3 rows 3 columns 1 0 0 0 1 0 and 0 0 1. This is a diagonal matrix in which each element of its leading diagonal is always 1. It's a diagonal matrix, but the principal elements in this diagonal should be equal to 1. It's called unit matrix or identity matrix. You can call it as a identity. Identity matrix will use the letter capital I. So this is equal to I. This is 2 rows, 2 columns, identity matrix, 3 rows, 3 columns. So these are the main 7 type of matrices in this. You can notice. And additional to one thing I'll show you, transpose of matrix. For example, matrix A is having elements 2, 3, 1, 0, 1, 4. This is one a rectangular matrix, right? If you want to find out A transpose of matrix, we can use this A to the power T. So you can use this denote like this, A to the power T. This you can use as transpose matrix. This interchanging rows to the columns. Now this first row 1, right? You can write as first column. This you can write column 1. So 2, 3, 1. Next to second row, you can write as second column. That is 0, 1, 4. So interchanging rows and columns. Transpose of a matrix. You can use transpose of a matrix is just interchanging rows to the columns. Interchanging its rows and columns. So rows to columns are interchanging nothing but even columns also interchange to rows, right? This is the column 1. It becomes as row 1, 2 0, 2 0, right? And second column in this 3 1, it becomes second row. This is third row. If you interchange rows to columns, it's nothing but columns to rows also. That means transpose of a matrix is the matrix obtained on interchanging its rows and columns, right? So these are the basic types. And we have the one more, equality of matrix. When we can say two matrices are equal. Let's say A is 3 1 0 4. Same place, same elements. So let's say B is also 3 1 0 4. Then we can say A is equals to B. A matrix exactly equals to B matrix. So corresponding elements must be same place, right? Then only A is equals to B. Let us say C is a matrix. It's X, Y, P, Q. If A is equals to C, then what is the value of X, Y, P, Q? A is equals to C, right? So first one exactly equal to the first one. 3 must be equal to X. So X is equal to 3. Then Y is equals to 1. Same way P is equals to 0 and Q is equals to 4. Whenever two matrices are equal, those corresponding elements should be equal, right? This is the concept used in the problems also next. When you're doing addition, subtraction, multiplication of the matrices, this concept will apply. Whenever two matrices are equal, those corresponding elements must be same, right? These are the types. Let us continue with addition and subtraction, the multiplication of the matrices.